This is Algebra 2 reviewing for second semester final on Unit 8, Graphing Rational Functions. So if we have the function 5 over x minus 2 and we want to graph it, first we have to determine if there's any vertical asymptotes. So where does our denominator equal 0? Well, x minus 2 will equal 0 at x equals 2. So that tells us that we have a vertical asymptote at x equals 2, and we can dash that on the line. This also splits our graph up into two separate sections, a right section and a left section. The right section happens to the right of the two, the left section happens to the left of it. So we're going to make an XY chart for both of them. So we want to start with a number close to 2 on the right-hand side, so like 2 1/4. Then we could do 2 1/2, and then maybe 3, 4, and 8. And we're just going to simply plug these in to our function. So 2 1/4, when it's plugged in for our x, so we have 5 over 2 1/4 minus 2, we get a y value of 20. Then we do the same thing for the next one. 5 over 2 1/2 minus 2, and we get a y value of 10. Now for the 3, 5 over 3 minus 2 gives us a y value of 5. 5 over 4 minus 2 gives a y value of 2 1/2. 5 over 8 minus 2 gives us a y value of 1 1/3. Okay, and then we plot those. 2 1/4, that's at 20, way off the graph. 2 1/2 is at 10, so about there. 3 at 1, 2, 3, 4, 5, right here. 4 is at 2 1/2. And then 8 is at 1 1/3. So we can take it and get an idea of what that side of the graph looks like. Left-hand side, same thing. We want to start close to the line, so at about 1 3/4, and then 1 1/2. And then I don't know, we could plug in 1, 0, -3, -8. So if we plug in 1 3/4, so we do 5 divided by 1 3/4 minus 2, we get -20. Next one, 5 divided by 1 1/2 minus 2, we're going to get -10. 5 divided by 1 minus 2, we're going to get -5. 5 divided by 0 minus 2, we're going to get -2 1/2. 5 divided by -3 minus 2, we're going to get -1. And 5 divided by -8 minus 2, we're going to get -4/5. So here, same idea. -20 is way off the graph. -1 1/2 is at -10, so about there. -1, -5. 0, -2 1/2. And then -3, 1. -8, -4/5. So then we have the idea of what this side looks like. So voila, there is our graph. State the domain and range. The domain are the x values. So for here, it's all the values for x such that x cannot equal this vertical asymptote. There is no graph exists there, so x cannot equal 2. So the range y such that we have to take a look at what it looks like y cannot be. And here, when we're looking at this, we have a gap of values that we're not entirely sure what value horizontally we're approaching. So if it's not 100% clear on your graph, what you can do is you can plug in a very large number. So I'm going to plug in 100 and see what we get close to. So if I do 5 divided by 100 minus 2, I end up getting 0.05. So now I see that I'm getting very close to 0. So that tells me that my y value cannot equal 0. That's going to happen on both the left side and the right side of the graph. State vertical asymptotes and holes. Well, we have a vertical asymptote. It's at x equals 2. Here we don't have any holes because we did not have something in the numerator and denominator cancel. And then finally, what is f of -3? Looking at our graph, -3 occurs 1, 2, 3. Here's x equals -3. We go down to our graph and see what our y value is. Well, our y value there is -1. So f of -3 is equal to -1.